When we visualize physical extremes on Earth, Mount Everest is our primary metric. We use its peak to define the absolute vertical limit of our world. But look at this scale. If you were to invert Mount Everest into the deepest part of the ocean, the mountain would be completely submerged. There would still be 2 kilometers of water above its base. This occurs in the Mariana Trench, a crescent-shaped trough in the western Pacific. Its deepest point is a small valley known as the Challenger Deep. The environment at the bottom is hostile. It is a world of absolute darkness, where the water exerts a physical pressure equal to the weight of 50 jumbo jets, pressing down on every square inch. These conditions crush normal machinery instantly. Because we cannot simply go there and look, we are faced with a logistical obstacle. How do we measure an environment that destroys our tools for observation? Mapping the deep ocean is a task of indirect perception. We have to find ways to observe a landscape that we cannot physically enter. The first solution was mechanical. In 1875, the crew of the British ship HMS Challenger began the first systematic attempt to measure the trench floor. Lacking electronic sensors, the scientists had to rely on a physical sounding line, a heavy rope with a weight attached. The crew dropped this weighted line blindly into the water. They waited for it to go slack to know they struck the seafloor. The rope descended for 8 kilometers before hitting the floor. It was the first tangible measurement of the ocean's true depth. This single data point proved that the ocean floor was not the flat, shallow plane scientists had previously imagined. This specific location was named the Challenger Deep, in honor of the ship that found it. In 1951, a second expedition returned to these coordinates aboard the HMS Challenger II. The crew replaced physical ropes with a more precise technique, echo sounding, or sonar. The ship emits sound waves that travel to the floor and bounce back. By timing the trip, the crew calculates the exact distance. These acoustic measurements revealed the true depth. The timer confirmed the seafloor was 11 kilometers down. Sound waves allowed us to see the topography of the abyss for the first time, mapping the jagged slopes of the trench using only echoes. Acoustic maps provided the coordinates, but the visual reality remained hidden. To actually see the trench floor, engineers had to design a vessel capable of surviving the 11-kilometer descent. In 1960, Jacques Piccard and Don Walsh used the Trieste, a heavily armored submersible built specifically to withstand the crushing force of the deep water. Piccard and Walsh successfully piloted the vessel to the bottom, becoming the first humans to physically enter the trench. 52 years later, in 2012, filmmaker James Cameron returned to the Challenger Deep for the first solo mission to the bottom. He used the Deep Sea Challenger, a specialized vessel built with modern materials to handle the weight of 50 jumbo jets without collapsing. By protecting the human eye from the intense pressure, these missions transformed abstract acoustic data into a visually documented reality. In 150 years, our perception of the ocean evolved from dropping ropes in the dark to bouncing sound waves to delivering humans to the absolute bottom of the world. Yet, despite these specialized vessels, the deep ocean remains largely uncharted. We have explored less than 5% of the seafloor. Every mission to the Challenger Deep provides new data on ancient geological shifts and biological life that exists nowhere else on the planet. The sunlit surface hides the scale of the world below. A jagged, violent landscape extends for thousands of miles beneath the waves. Earth's greatest uncharted frontier is not found in outer space. It is hidden in the dark, high-pressure depths right beneath us.